So can I open proceedings in terms of the discussion just to take questions in relation to Alan's paper and Andy's paper that we've just heard? Any questions or comments? Yes?
Just we hear about precocious names. I mean, certainly when he was doing his model, when he was talking about his model, he was saying they ignored the sex element of it. But maybe the fact is that some rivers do have precocious male par, which fertilise adult females, and we all know that sex stunts your growth. So it could be that it's affecting the length of the fish. So you could be getting smaller fish where you're getting a preponderance of precocious males, and also, the difference between the Tamar and the Frome might be that there may be more precocious males actually doing the business with the adult females. Just a thought. Have you got any information on precocious?
The difference between the Frome and the Tamar was for sea trout. So you don't get precocious males in brown trout because you've got that resident component. So what would be a precocious male in a sea trout? It's just a resident fish.
Well, I'm just saying that it might affect the length.
Oh, of course, and that's one of the things with the, that might be one of the conclusions you could draw from the salmon sex ratio in the Tamar. If that's indicative of the run as a whole, it could indicate that you've got a lot of precocious male par remaining in the river. Yeah.
Thank you. Any other questions? Yes, Roger.
Thank you, Ken. A comment on what you said about apparent sex differences in mortality rate between smolt and school peel. I think we mustn't forget that the sea trout divided migration and return is so plastic. A very significant number of fish do not come back as school peel, but come back as maidens and then come back as repeat spawners. And it may not be mortality, it just may be a longer retention time at sea. And I think we just need to be wary of that, of drawing easy conclusions in a very plastic species.
For some rivers that would be the case, but the sea trout run on the Tamar is dominated by finnick and those that have spawned once. The one sea winter maidens is a fraction of a percent of the run. So for some rivers that might be the case, but for the Tamar, I don't think it would be.
The other comment I'd make on the two papers is how important some of the data on sex ratios and survivals from fry to smolt is in the way that we calculate stock size, which then is translated into fishery management measures. Interesting that you said that Alan G's work in the late 70s was really the basis of our knowledge of survival. From memory, some of the work that Alan did on the Y suggested that in dense populations, you actually get depensatory mechanisms where over-egg deposition results in a lower smolt production than a smaller egg deposition. I think we're in danger of not using all of the evidence that we have in regulating our fishery exploitation in an oversimplistic way. That's a comment, not a question.
Could I perhaps just make a comment in relation to what Alan had to say, just to emphasise it? I had the opportunity many years ago to actually look at a full river system in great detail. So we looked at the tributaries and we electrically fished the main channel as well. When we did our sums at the end of year one, we realised that the areas that the local regional fishery officers brought us to didn't at all account for the production in terms of the production of smolts relative to the number we calculated from the adult returns. So we went back and we looked at the main channel, and it was quite extraordinary. In the main channel, we identified 3 areas that we actually described as the redding areas. They were less than a third of the total length of the actual river length itself. and they were disproportionately important in terms of producing those juvenile fish. So I think the point that came out of Alan's model is really important, because we've almost regressed in terms of this idea of the wetted area. Because certainly Phil McGinnity and I, when we started in Burrishoole, we actually started doing the right thing by actually allocating the specific habitat components and modelling those. And then, because it was only possible to do wetted area in the context of the removal of the drift nets and looking at a national model, suddenly the wetted area became the bee's knees. So I really think that we have to look again at that whole area of actual habitat components and trying to understand the parts of the actual rivers that are producing the smolts. I think it's a vitally important point. So any other, yes, Richard, and then one at the back, yeah.
I suppose thanks, Ken. I suppose the implication, Andy, is that you've looked at the fish that are going out to sea. So the resident fish then, I presume, would have a bias towards males as they get older. And I just wonder, is it something you have looked at or intend to look at? Because we think we've seen the same thing in Northern Ireland on a couple of our sea trout rivers in terms of the resident fish.
Yeah, it's one of those things I would like to look at and look across, from fry through to the resident adults, as well as looking at the smolts and the sea trout. They should be male biased. Given the number of females going to sea, they should be male biased. And some of the work that I found that's been published would back that up. But then, I'd also like to look at somewhere like the River Exe, which is a fantastic salmon river, but has got bugger all sea trout, and see what the sex ratio across the age range of fish there is. That, do you still get a male bias sex ratio in the adults, or do you get perhaps a female bias because they're not going to sea?
Thank you. Just to comment on that, because certainly in Ireland it does appear as if there's at least two types of systems, one of which has a small migratory component and a very large resident component. And then in the context, I think what Andy was talking about, maybe they would be the migratory component. Perhaps we'd see that bias towards males, but it may be swamped in the context of the residents. That's because you won't really be able to tell at that size. Brian, you, I think, wanted to ask a question.
Yeah, my question was for Alan regarding wetted areas, which has become quite topical in Scotland with the introduction of the conservation regulations. So my question is quite simple. How do you define wetted area and how do you measure it?
Well, for me, it was very simple. We just went to the Ordnance Survey maps and took them. There's an Ordnance Survey map now that includes a width. So certainly for second order streams and beyond, you can work out the wetted area from the zones. For first order streams in the maps, that's still just a single line. So we did have to simplify that, and we applied an average width of 1.5 meters per length for there. But it's just down to the maps. I have to say that from the eel world, one of the things that makes this kind of relatively simple is that we're comparing now with 20 or 30 years ago. And to some extent, as long as we're consistent in our method between these two different periods, at least you're comparing like with like. Moving it into the salmon one, where we're only looking at now, draws out all of these niggles and issues about how we do. But the wetted area is done from mapping.
Yes, one on the right and then one on the left.
Well, just to say, picking up the point about sex ratios of trout, this is what we're actually doing on the Tweed at the moment, using this genetic sex test. But we're using it as a way of distinguishing populations being dominated by resident or migratory trout. And we've only started this. We've got some results from a loch population of trout, and we get that 50-50 male and female, which you would expect in a resident population. But in other parts of the rivers, we found it dominated by the small resident trout dominated by males, which we are taking as a signal that these are essentially sea trout populations. And we've just sent off another batch to be done. But this is all based on tapping work we did in the past. We found very clear differences between streams that were dominated by sea trout, with half a dozen female sea trout, 100 little male brown trout, and proper brown trout population, 50-50 and pretty much equal size between male and female. And one of the drivers for doing this is to understand the brown trout population between, because that's the one that the anglers, a lot of anglers are using, the angler clubs are using. What are the sources of the trout that the anglers are catching? And our hypothesis is that for the smaller sizes of trout, they'll be male dominated, because they will be largely the male part of sea trout populations. But for the large brown trout, once the anglers really want, we think those will be 50-50 male and female, and they'll be coming from brown trout populations. So that's the way we're using the sex differentiation to understand the structuring of different trout components of the creek.
Brian, you had a question?
Just listening in, and this is really, really exciting. I really think that this adding component of the sex ratio can really help us to understand and get more accuracy in the modeling. So this can be really, really important in the future. Just want to ask Alan a little bit about the modeling as well. You had used wetted area, and of course that gives an overestimation about 90%, quite a lot of the productivity area wasn't really productive. And Ken also mentioned that the wetted area doesn't contribute evenly to productivity of the par. So I wonder if, I know in the Baltic that they're using some habitat mapping to really show what kind of data or area is reproduced in par. But that can be quite time consuming. Do you have any ideas what kind of parameter that could be used easily? Are you using slope, or what kind of data could be used to get more accuracy? Now you said 1/10, and that ended up more accuracy. Was that just by...
That was just a fudge. Yeah. I can't give you a good answer on the sort of the characteristics of habitat mapping, but I think there's probably other people in the audience who can. And I know that certainly in a few meetings I've been at in the last year, there's a lot more discussion about how we could better map habitats around river basins to be more characteristic.
Yes, you want to make a comment?
Yeah. Just Alan.
Yeah.
Alan, I think we should switch systems, you and I, because we did the same thing back in the 80s, and we actually went out and measured, built this small model based on all the mortalities from step 1 to step 2 and so on. But we went out and actually tried to give a score, habitat score for each of the habitats, so we could say here's habitat 4 and 3 and 2, and some were productive and some were not. And then we actually added up the whole. It was quite a small system, about 50 square kilometers catchment. But anyway, so we did the same stuff, and then we of course put up the trap, a total trap, which cost everything that we would. And the model showed us that we will have 5,000 sea trout smolts from that area, and when we put up the trap, immediately we caught 35,000. So we're like, that's the opposite problem. It turned out that actually what we thought were habitat was true enough habitat, but the main channel of the river, which we thought were basically just a desert because it was quite deep and quite slow flowing, was a great growth area for the little part that moved out from the tributaries. We have the spawning tributaries, but they came out, so there was a huge growth out there in that channel. So actually it can work the other way too, which means that you have to test the models and put up traps, and that's the way it goes. Yeah.
Phil, you want to make a comment?
Thanks very much, Niels. I think there's just a little bit of confusion about the wetted area models and so on, and what they're used for. You know, this idea of getting a measurement. A lot of the conservation limit, assessments, so on, they're based on stock and recruitment relationships. So you take a number of systems where you have very good information, the kind of thing that Niels is talking about, where you have actual census data, and you have long-term census data, and you use that data then to drive a stock and recruitment relationship, and you try and understand what the underlying function there is. So what you're trying to do is to transfer information from those stock and recruitment relationships, where you have that very good information, to other rivers, which are the majority, where you don't have that information. And the standard way to do that is to say, right, okay, we've got latitude or some function of productivity that might be based on latitude or whatever it is, the kind of things that Elvira was talking about earlier. And the way you transfer it is based on wetted area. So you might say these systems, so many eggs are required per metre squared. So in a way, that's what's driving it. In terms of, just Chris, there, one of the, how is, a lot of the time, what wetted area are you measuring? Well, one of the standards that they use is to say at dry weather flow, where it's groundwater is, is feeding the system or charging the system. And then say some of the models that we've used in Ireland, they're based on relating dry weather flow, measured dry weather flow, to a whole range of different reach types, first order, second order, third order, in different geographical areas, and then modelling that up. So you might have 10,000 observations, and you model that, and that's the kind of thing that you would use. But the key thing here is a lot of the terms, in terms of estimating, what the carrying capacity is, or how many eggs you should be putting in, or whatever it is, it's really you're trying to translate rivers that have information on stock and recruitment to rivers that don't, and it's just a medium to do that. Is what's going on there. However, that's not to say that absolutely different habitat types, depending on gradient and so on, are going to have different productivity values. Quite often, say in the Irish situation, in many of the systems, we have lakes. So we measure the wetted area as a way of transferring from one stock and recruitment relationship to another. But many of them have lakes, so you get greater productivity per your metre squared of wetted area. But the models, what you're trying to do in having many models, so say in the Irish situation now, we use British and Irish rivers. I think there's 13 or 14 of them in the database. And we're hoping that all those 14 rivers incorporate all the variability around water quality and gradient and lakes and so on, so that we have some metric to transfer. So it's really only a transference mechanism rather than actually trying to get what each metre squared of a particular type of habitat would confer.
Now, obviously, at this stage now, we'll throw it open for all of the papers, including the small ones. Any general comments to be made?
Okay.
A question really about smolt survival at sea and their lifetime at sea. Back in the good old days of waterboards, we did some surveying on the River Tees, which was the second largest tributary of the Severn, and we found a high proportion of our smolts were great big bruisers. They were 3-year-old smolts, big fellows. And we assumed that these would have a higher survival rate at sea. We also assumed that they'd come back as SW2, SW3, even SW4 fish. Well, we were right on the first count, but they did survive better. But these big bruisers, they didn't like it out in that cold, deep seawater, and they came back as mommy's boys, as grills the next year. And I just wondered if anybody else has seen a similar pattern on other rivers, that these big smolts, they might be great and survive better, but do they turn out to be the big springers, or are they just coming back as grills?
Can you answer that?
There's a challenge. Certainly in the context of the...
Thank you. In the context of what they're about maturing. So if they're very large like that and they mature when they go to sea, or get all the physiological signals that they're maturing when they go to sea, they're going to come back to you as grills, I think. So, any other comments on that? Yes, Niels.
I can shout out. I don't even like.
Okay, that's fine. We'll challenge you. Yeah.
Well, I think most of the people here know that this has been proven off through the 50s, 60s, and 70s that small smolts make big salmon and big smolts make small salmon. So everybody, at least in Scandinavia, always tries to avoid having the big smolts. That was one of the big problems by these hatchery-raised fish that were so big and fat, and they came back, some of them, but they all came back as tiny, scrawny little grills. So we always, at least in our management in Denmark, tried to aim for small smolts. We didn't want those big ones. So, simple answer. I haven't seen any papers from anywhere where it was different. If you have a grills river that's running only with grills, yes, then maybe you are happy with big smolts, but we're certainly not. We like the smolts the better.
Any other questions or comments? Yes, Roger again.
Thank you, Ken. Really, this is picking up on Andy Brown's presentation, which was similar in outline to one that he gave in Newcastle several years ago, which effectively says micropollutants are having a significant potential impact on smolt survival. And this is really a comment or a question for the Environment Agency, which last year launched its, with much fandango, its 5-point approach to restoring salmon stocks in England. I and several others are working closely with the agency on how we can reduce exploitation by rods and nets. I think one of the 5 points of the 5-point approach is improving marine survival. Given what Andy showed us today, given what he's shown us before, I think the challenge for the agency is what are you going to do about those micropollutants which we know exist and which we know are having a serious impact on marine survival.
Thanks very much indeed. A challenge thrown out. Anyone want to field that one? Not so far. Yes. Lawrence is going to answer this.
Well, it remains a challenge. I mean, the work that Andy cited on the Avon, and I think he also did work on the test that I was involved in terms of atrazine and its impact on smolts. I mean, the good news is atrazine is now banned, and it shows how important it is to have the evidence to then bring in measures to control such circumstances. You know, if there are other findings pointing in a similar direction, then you know, we should discuss that in terms of bringing in controls against such chemicals. But otherwise, we do monitor the status of water quality in all our salmon rivers, and yeah, there are some concerns relating to particular chemicals that we're picking up through such monitoring.
Thank you. Any further points? Yes, Dave.
Yes, thank you. I had a question concerning the boar shoal, and I guess it's for Elvira. You indicated the study area had various stockings of different genetic groups and aquaculture fish, etc. So I wondered if you have any concern that those different strains or different situations over the years may be influencing your results, because you were looking at time trends and series, but you have different mixtures in there. That's what I was concerned about.
Yeah, you're absolutely right. Well spotted. They were all various mixes of farm fish, hybrids, some own moor fish, another wild river. So it was, you know, that was the data that we presented there was like a first blast analysis to look at all those. But in that data set, there are also pure wild cohorts. So that will be the next challenge. And we have a new postdoc who maybe is going to take that up to try and model it with the origin as one of the explanatory variables.
Thank you. Just to emphasise the point, in case anyone missed it when Elvira gave her paper, they aren't all going out to sea and coming back as a mixture. Obviously, anything that isn't of pure wild origin is actually sacrificed at the trap, just to make that point. That's the whole point of that isolated area, so that there's no integration.